So let's talk about Python. We're here to talk about how to write cleaner, safer Python code with SonarQube. I'll jump right in. I want to start with SonarSource, which is the company behind SonarQube. SonarSource was founded in 2008 by 3 developers who got together with the goal of giving other developers better tools for code quality and security. The goal then and now has been to write tools for developers and development teams, not managers, but developers, that are simple and transparent and easy to integrate into your development process. And oh, by the way, accurate and helpful always. And specifically what that means is no false positives. Now that's not a promise, we're human, but it's our goal, and it's our promise that it will always be our goal to get rid of false positives. So our mission statement is that every developer and development team should use our products for code quality and security, and we see that as mission possible. And specifically, we see it as mission possible that every Python developer and development team should use our products. So let me tell you why we think that's possible. With SonarQube, you get a static analysis that's powerful, fast, and accurate out of the box. We've worked hard to give you valuable rules that raise real issues, to give you tools that work where you do and that work with minimal configuration. So let's start with the rules and issues. We divide these into what we call the 3 pillars: maintainability, reliability, and security. And starting with maintainability, this is about more than naming conventions and tabs versus spaces. There have been multiple studies about where the time and therefore the money goes in the life of a project. And different studies come up with different numbers. Some studies come up with numbers as high as like 96% of the time spent on a project is spent in maintenance, right? So that's 96% of the time that goes into a project is spent reading old code. So the more readable you can make that code, the more easily understandable you can make it, then as a developer, that's less time you spend figuring out what it does and more time you can spend actually writing cool code to solve problems, which is why you got into this to start with, right? So Nicola, so in just a second, I'm going to turn it over to Nicola to tell us about some of the maintainability rules. But first, I want to point out, he said earlier that his job is as a code quality researcher. Specifically, what that means is that it's his job to look at a language and figure out which rules are needed for that language. And then for each rule to write up a really good description so that when that rule raises an issue on your code, you can understand very easily why there's a problem and what you need to do to fix it. So with that, now Nicola, could you show us some of the maintainability rules?
Sure. Thank you, Anne. Good. I'll go over a few CodeSmell rules to show you how we design and categorize them. In this example, the developer checks if the built-in int returns none. This is overly defensive programming, as int can only return integer numbers. SonarQube will raise an issue on the none check, explaining that it will always be false. The checks usually have no effect on your program, it won't crash, but they confuse developers coming behind you. Here is also a common Python pitfall. We can see that the issue highlights 3 locations in your code. First, the attrib parameter, which has a dict literal as its default value. Then the issue highlights location where this parameter is modified and assigned to a class attribute. Why? Because in Python, every call shares the same parameter default value. Modifying this value in one function call will impact every subsequent calls. Sometimes this is done on purpose, but most of the time it's either a bug or a bad design. This rule accepts caching as a valid use case, and it only raises issues if the default value is modified or assigned. And here is the last CodeSmell example. The format method is used to format a string. In this case, the first parameter will be correctly inserted, but the second one will be ignored because there is no matching replacement field. This could just be some dead code left after a refactoring, and it won't make your program crash again. So we only raise a CodeSmell issue, not a bug one. From those few examples, you can see that we avoid raising unnecessary alarms. We will help you maintain your code, but we won't shout at you every time something might be a bug. Back to you, Anne.
Thanks, Nicola. So now let's move on to the reliability pillar. Reliability rules raise bug issues, and I think it's obvious to most people why you don't want bugs in your application. So the bug rules that we provide help you make sure your code is going to behave as you expect at runtime. Could you show us some of those rules, Nicola?
Yes, thank you, Anne. You remember how I said that we avoid unnecessary alarms? Well, for bug rules, it means that we're quite sure that the issues are really bugs. We saw previously that unnecessary non-checks can be confusing, but comparing with the equal operator two incompatible types, such as a string and a tuple, is always a mistake. You can see this exact case here. The architecture function always returns a tuple, so the equality check will always be false because it's comparing it to a string. It won't crash, but it is most certainly not what you wanted to do. We also detect usual copy-paste mistakes. If you write twice to the same key of a dictionary without reading the value in between, you probably copy-pasted some code and forgot to change the key. This actually happens quite often. Another common problem in Python is the difficulty to refactor code. Add one parameter to a function and every call will break at runtime. Luckily, SonarQube helps you detect these invalid calls. And the final bug rule, I already mentioned a code smell rule detecting string formatting problems, which don't crash, but make your code difficult to maintain. Well, we have an equivalent bug rule which raises issues when code will fail at runtime. Here, you can see that the developer used replacement fields 0, 2, and 3 instead of 0, 1, and 2. As there is no value for field 3, the format call will raise an exception. Separating code smells from bugs enables you as a developer to know what you should fix right away. Back to you, Anne.
Thanks, Nicola. So now moving on to the security pillar, we actually divide that into two subcategories, and I'll start with vulnerability issues. Just like the distinction between code smells and bugs, we make a distinction in security between vulnerabilities and hotspots. Now I'll come back to hotspots, but I'll start by saying that when we raise a vulnerability issue, what we're saying to you is there is something here that needs to be fixed. So security issues put your systems, your users, and your reputation at risk. They're like an open door to your house, right? If your front door is standing open and a thief walks by and sees that, then you're going to end up having a bad day. And vulnerabilities are the same way. So our approach is to raise vulnerabilities as early in the process as possible. While the code is still fresh in your mind, you remember what you intended, and it's really easy for you to do the fix and move on with your life with secure code. Could you show us some of these rules, Nicola?
Yes. A common mistake for a developer is to disable security features and forget to remove this code before going to production. SonarQube is here to warn you when you do this. For example, you develop a website and generate an SSL certificate to test it. You then disable certificate validation as your certificate is self-signed, which means that it's not signed by a certification authority. SonarQube detects this issue for multiple libraries such as PyOpenSSL and Request. Even when you avoid this kind of mistake and follow security best practices, you might forget to update your code regularly. Let's say you use cryptographic keys such as RSA or DSA. The recommended length for a key increases with time as computers crack them more and more easily. At SonarSource, we have a dedicated security team improving our rules constantly. As standards evolve, you will get notified that you need to update your code. Our security team also works on SonarQube's taint analysis engine. It enables us to detect vulnerabilities such as cross-site scripting or XSS, which is the most common vulnerability in Python open source projects. To make it simple, SonarQube detects when dangerous data can be injected by an attacker and sent back to your user. So here from a request to make response. Our security team improves these rules constantly to detect more issues, but also to avoid false positives, as Anne said. We will not raise any issue if you sanitize the data before sending it back. Back to you, Anne.
Thanks, Nicola. So now let's talk about the other half of the equation, security hotspots. I said that when we raise a security vulnerability issue, we're saying to you, there is something here that needs to be fixed. On the other side of that are security hotspots. So there are times when you're using a security sensitive piece of code, but static analysis is unable to detect whether or not there's actually a problem. These are the places that require human review to know whether or not there's a problem. So you need to go in and look at the security sensitive code in context to determine whether it's fine and you can move on, or there's actually something here to be fixed. I like to think of these as Schrodinger's vulnerabilities, because you won't know that there's a vulnerability until you take a look. So with security hotspots, we segregate those issues from the rest of the issues to make it super clear this is not necessarily a problem, it's just something you need to come review. And we give you the tools and the context to look at each one and understand for sure. Can you give us some examples of this, Nicola?
Yep. Thank you, Anne. So let's see a few cases where you should really double check your code to see if it is secure. As a developer, you might expect that libraries' APIs are safe by default. Sadly, it's not the case for every library. Let's take the example of Flask setCookie method. By default, it will not set the secure flag to true, and cookies will be sent over HTTPS, but also HTTP. When they are sent over HTTP, anybody can read or modify the data you send and receive. In some very rare cases, it is okay to use HTTP, which is why it's not always a vulnerability. But most of the time, only HTTPS should be used. Even with safe connections, your browser can still be vulnerable if the JavaScript it executes can connect to any server. CORS policies have been created to prevent this from happening. But as always, you can disable them if you want. SonarQube will help you see if you can do it safely or not. Let's finish with a very simple command, which you have probably used a lot. If you open a file, like here, for example, /tmp/f, an attacker could create a symbolic link with the same path and point to another file. You will then write to this other file without even realizing it. You could, for example, overwrite the password file of your server. Most developers are not aware of these risks, but once you know it, they are pretty easy to avoid. Each security hotspot rule provides a checklist to guide developers and help you take the right decision. Back to you, Anne.
Thanks, Nicola. So now let's talk about where you get these rules and issues. First, we provide static analysis in IDE with SonarLint. This is a plugin that's available for VS Code, which is what you're seeing here. It's compatible with IntelliJ and also specifically with PyCharm and for Eclipse. This is free and open source. You can get started with it today just by installing it. Next, we provide PR analysis and decoration so that once you have committed your code and you're beginning to collaborate with your teammates, we're going to run those checks against your code so that then your reviewers don't have to worry about looking for the normal suspects, right? We're going to detect those for you, mark it up in your PR, and then as a reviewer, I can focus on the code, the implementation, the logic, rather than looking for, the boring stuff. We do that for you. And next, there's the SonarQube interface, which we provide as a centralized place to coalesce the team around a shared vision of quality. So with the SonarQube web interface, all of the stakeholders of a project can come see the current status of the project at any given time, understand what needs to be worked on in order for the project to be releasable by the standards that you set for your own team. All of this works with minimal or no configuration. So there's minimal setup to this, and I'll talk about that a little bit more during the demo. Analysis is fast and thorough, and out of the box, you're going to be running with a non-controversial default rule set. So what I forgot to say earlier was Nicholas showed you 3 or 4 rules from each category of rules. We offer a total today of 170 rules. That's 44 bugs, 25 vulnerabilities, 23 hotspots, 78 code smells. Not all of those are turned on when you first unbox SonarQube, right? We have a default rule set, which is a smaller set, and these are all going to be rules that when they raise issues as a developer, you're going to look at these issues and you're going to go, yeah, we need to do something about that. Now, there are additional rules that are available that might be appropriate in your situation for your project that you can additionally turn on. But out of the box, you spin this up and you should be getting a great experience. So now it's time to show you that experience with the demo. So I'm going to make my window a little bit smaller here so I can get to the console. So here is my empty SonarQube instance. What I've done here is download the zip, explode it, run the startup script. Because I'm running Developer Edition, I did before this demo configure it with the license key. But if you're running Community Edition, you don't need to do that part. So here in my console, I have CD'd into my project. I have installed Sonar Scanner and a JDK on my machine to run it on. And I've put Sonar Scanner in my path. Now I can run analysis with almost no configuration. I do, however, need to give the server a key to identify my project by. So -D for define sonar.project key equals demo, and I hit return and analysis starts. The first thing that the analyzer does is reach out to the server and say, okay, what version are you? What rules should I be applying in this analysis? And it downloads those, and then it's going to start stepping through the project, looking at all the different files. Now, I want to give you a little bit of background here. I said that I'm running a JDK on my machine. That's required for the SonarQube server itself, so you do need to have Java installed. And then probably you want to be running as a service. I'm just running it from the script directly. But after that, setup is pretty simple. You download the zip, you explode it, you set up your service, you start it up, you're good to go. And then here on the analysis side, as I said, on my analysis machine, I've got Java running. I've installed my scanner and put it in path, and that's it. Now, you can provide additional configurations, and you can do that either by providing a project settings file, or you can do it on the command line like you just saw me provide the project key. So looks like we're getting into the Python files now and stepping through those pretty quickly. So what's happening here is SonarQube is going through, excuse me, not the SonarQube, but the scanner is going through each file, and it's sort of racking up a list of issues and metrics on each file. At the end, it's going to compile everything it's found into an analysis report bundle, and it's going to shoot that bundle over to the server. The server is going to receive that and put it in a queue, and then it'll pop the queue as it has availability to process a new report, explode the report, and it's going to save the issues, save the individual file metrics. It's going to aggregate some higher level project metrics, and then analysis is over. So we're almost done here. In just a second, it'll be checking the SCM data, and that allows it to understand which lines in a file are new, so which issues are new. It also helps it understand who owns issues so that it can properly assign those issues to their authors.
If I can interrupt you for a minute, Dan.
Sure.
We have one question about SonarQube and Django support. Yes, you can analyze Django project with SonarQube and actually Flask project too. We have rules like the XSS rule, which I showed before, which will support the source and sinks for different web frameworks.
Great, thank you. So I think analysis is almost done here. And I do just want to point out, so when Zoom is not taking half of my processor, analyzing this particular project takes minute 37. As you see, it takes a little bit longer with half my processor gone, but analysis time is entirely dependent on the resources available on the analysis machine on one hand, and on the other hand, the size of your project. But analysis is complete now. The analysis report has been submitted to the server. So if I come to my projects list, I see that the report has been processed. So I'm going to click through, and here's my project homepage with my aggregated project level metrics. But I want to talk about the issues today. So I'm not going to spend any time on the homepage. I'm just going to jump straight into the issues. And the first thing I want to do is point out that even though we're here to analyze Python today, for the price of that one simple analysis command, I got analysis of not just the Python in my project, but all the other languages as well. So also the HTML, JavaScript, PL SQL, and CSS. But we are here to talk about Python, so I'm going to narrow my list of issues to that. And when I do, I see that I have 10 bugs, 8 vulnerabilities, 261 code smells. So let's dig into this a little bit. If I click on the bugs, I narrow my list further, and I start to see my remediation messages, and I see what file they're in, what line they're on. But having a message in a file on a line isn't terribly helpful to me. So either I can click on this box or I can right arrow on the keyboard to see the issue in context. So my issue message is remove or correct this useless self-assignment. And when I get here into the code, I see that sure enough, I'm assigning SQL to SQL, and that's probably not what was intended. So I've got a bug here. This needs to be addressed. So moving on to the next one, and I'm just going to arrow down on the keyboard to get there. Here I've got remove this return statement from this finally block. So I've got there's my return in my finally. Now, if I'm not familiar with Python, if I'm new to Python, it might not be super obvious to me why this is a problem. So that's why the rule description is close at hand. And this is what Nicola wrote up to help you understand why we're raising an issue. So for each rule, I'm going to have a description that explains why there's a problem, what bad thing might happen if you don't follow the rule. And for each one, I have, for most rules, you're going to have a non-compliant code example, which shows you what broken code looks like. And then additionally, we have a compliant solution which shows you the broken code fixed so that you have a model for fixing your own code. All right, so I'm going to close that out, and I'm going to go back to my list and look at the vulnerabilities, and I'm just going to right arrow into the first vulnerability. Add password protection to this database. So I've got a key of password and a value of empty string. So yeah, that looks like I'm getting into a database without a password. I probably need to put a password on that database. So moving on to the next one. Now this one's a little bit more interesting. You're seeing a more intricate interface here. So it's telling me that I'm constructing a SQL query from tainted user-controlled data, and I've got a lot of extra locations here. Over here on the left, I've got my list of secondary locations, which is collapsed by default. So I'm going to expand that, and I see that I'm going across 2 different files. And I want to see where this starts. So I can either click on the one, or I can hit Alt on my keyboard to jump to the first location to see that I start by getting a value from the user request that gets Alt down assigned into a variable, and then it gets churned through some other methods. until finally it gets executed as SQL. So, and all of that without actually being sanitized, without actually being escaped or cleaned up, right? So I'm taking the raw user data and stuffing it straight into the database. Probably not a good idea. If this were my code, I would want to get that cleaned up. So I'm going to go back and just look briefly at the code smells. I don't want to take time to go through all of these 261 code smells, but I do want to point out the distribution of issues across the rules, because this is a little bit interesting here. So we've got 107 instances of duplicated string literals. So that's certainly an opportunity for cleaning up. We've got a number of cognitive complexity issues. Cognitive complexity is a method of measuring understandability that we invented here at SonarSource. And it can be really helpful to make your code more readable to reduce your cognitive complexity. And then we've got a number of others. Collapsible if statements. This is one of my perennial favorites. So I'm not going to go through all of these, but I just wanted to point that out. Now, what you're not seeing in this list is hotspots. You know, we gave you 4 categories of rules, but you're only seeing 3 of them here. And that's because we do segregate hotspots into their own separate category. We give you an entirely different interface because, again, we want to emphasize this is not necessarily a problem. It's just something you need to look at. And so here's the interface we give you to review those hotspots in the context of the code. So here on the left is my review queue. And then on the right, I see the issue in context. I've got the rule description to help me understand what could go wrong here if there actually is a problem. I've got the criteria to help me understand whether this particular instance actually is a problem. And if it is, what I can do to make the problem go away. Now, if I think that this particular instance is actually okay in this context, what I can do is mark this safe. And once I change the status, it's going to take this one out of my queue because it no longer needs to be dealt with. But if I think that it actually does need to be handled, I can assign it to someone to handle. Now, we're looking at a demo instance with no other users, so that's why only administrator shows up here. But that's hotspot review. And that's what I wanted to show you in the SonarQube interface. So now I'm going to jump back to the slideshow and talk about additions a little bit. So 95% of what we've talked about just now is in Community Edition, which is free and open source. It gives you the powerful, fast, accurate static analysis that you've just seen with all 4 issue types. When you move up to Developer Edition, which is the lowest commercial edition, you add on taint analysis. So that gives you the SQL injection issue that I just showed you, as well as PR analysis and decoration. The next edition is Enterprise Edition, and this adds some management features. So you get portfolio management, executive reporting, security reports. So in summary, with SonarQube Python static analysis, you get a fast, accurate static analysis that gives you valuable rules and issues. It works out of the box with minimal or even no configuration. That's what you just saw in the demo. For developers, we give you this static analysis in IDE with SonarLint, in PR decorations with Developer Edition and above, and for teams with SonarQube itself. And that's it. Nicola, are there any questions we need to answer?
Yes, we have some questions about different editions. So the first one would be, are the rules updated in the community edition too?
Oh yes, absolutely. So every edition, every new version adds new rules. Now, not every language gets new rules in every version, but Python is one that we're actively working on. And the vast majority of the rules are available in Community Edition. It's only those taint analysis rules that follow the untrusted user input from where it comes into the application to where it goes into things like files and SQL, that sort of thing, that show up in Developer Edition. And And I'm sorry, I know I asked you for questions, but as I was doing that, my eyes fell on the time, which is 11:31. So we're actually over time already. It looks like we lingered lovingly on too many details here. And I do have one more slide that I need to hit before we quit. So I'm sorry, I'm not going to give you time to give me any more questions, Nicola. I am just going to move on to the wrap up. So please, please, please take the survey that you're going to get in just a minute. Please tell me what we need to do better, what you'd like to see in future webinars. If you had a question that you posed that didn't get answered, we are going to be following up with that. You'll get an email with a link to the answers. We post those in our community. And you'll also get an email to a recording of this session in case you want to watch it again or share it with your colleagues, whatever. You can find more information about our Python analysis at sonarcube.org/Python, or you can just jump right in and download it at sonarcube.org/downloads. Thanks everyone for joining us, and maybe I'll see you again at the next webinar.